Hello and welcome to Basics of Projectile Motion. Now, projectile motion is very easy once you get everything understood. Now, some of the basics projectile motion, you have time, which is usually represented by a t. It is always measured in seconds for doing calculations. You have the change in position, which is usually represented by a change in x, change in y, or just an x, and it's usually measured in meters. You have velocity, which can be represented as a final velocity, an initial velocity, or just as the average velocity. That wouldn't be there. And that's in meters per second. You also have acceleration, which is how fast the velocity is changing. That's usually measured in either the x or the y direction. That's always in meters per second squared. Now, in projectile motion, there are three basic formulas that you use, and upon using these formulas, you can pretty much solve for any of those variables there. There's the change in x equals the initial velocity times time plus 1/2 acceleration times the time squared. There is the final velocity equals the initial velocity plus the acceleration times the time, and there's the final velocity squared equals the initial velocity squared plus 2 times the acceleration times the change in x. These are the three major formulas that you'll be using throughout the problems. Now, projectile motion in two dimensions really spawns from the whole idea of if we have a ball, it's rolling along a flat surface, imagine this is flat, everything is in the x direction. You have the ball, there's a change in x, which is how far from here to here, you have the time that it takes to go from one to the other. You have its initial velocity, which if there's no acceleration, equals the final velocity. And in projectile motion, it's just like this. There's no acceleration in the x direction because we are negating air resistance in these problems. And then there's acceleration, which I just said is 0. So there you have all the variables that you need, and I prefer to list them out in this way. So you do time, v naught, v final, acceleration, and the change in x. This way you can keep track of all your different variables. Now, what about the y direction? In the y direction, say you have a ball, and now it's falling. So there is an acceleration. So you have time, as always, it's just t. You have a change in y, which equals some meters, because it's falling, the initial velocity, and the final velocity. And since there is an acceleration, on Earth that acceleration is negative 9.8 meters per second squared, these don't equal each other anymore. So then you put them together, and you say you have a ball, but you throw it. So it's got an arc to it. So now you have it both, now you have to worry about both the x and the y directions because the initial velocity of the whole system is this. You get this initial velocity, but how does that relate to these? It's very easily, actually. If you realize this is a triangle, you have an angle here, theta, and then this is the initial velocity in the y direction, this is the initial velocity in the x direction. So if we know this is, say, 25 meters per second is the initial velocity of this ball on this arc, then we can figure out that using trigonometry that what v naught y and v naught x are, using sine and cosine. So yeah, that's just the basics of projectile motion. And when doing these projectile motion problems, I usually list them out. So you have t at the top, because that's the one thing that both sides share. You have a common variable there. And then you do the acceleration in the x and the acceleration in the y. And the reason we keep them separate like this is because you can't use anything here to get anything over here. So like if I have all of these, But none of these, I can't really determine anything over here because all I have is time. And these don't really affect this. So this is just a good way to set up your problems to make sure that you have all the variables and you're keeping track of all the variables. Because while these projectile motions seem as though they're very complex, they actually are not. They're actually quite easy as long as you keep everything straight. So yeah, yep, that's a good introduction for you.